Hi, in this video we are going to see the derivation of the Fourier series coefficients of the half-wave rectified sine signal. So first of all, let us give the definition of the signal. Now define the pulse P of t as the lobe of the sine signal from 0 to pi. Okay, the maximum value is chosen as 1. So P of t is equal to sine t for t between 0 and pi and 0 otherwise. So we have this single pulse. Now let us obtain the periodic signal x of t as follows. Let x of t be defined as m from minus infinity to plus infinity, P of t minus 2 pi m. That means we are defining a periodic extension of P of t with a period equal to 2 pi. So if we plot x of t x of t will be the following periodic signal. The repetition of that single lobe with a period equal to 2 pi. So this is the periodic signal. Again, the amplitude is taken as 1. Okay. So the period is, the fundamental period is 2 pi. This is our fundamental period. Therefore, omega 0 is equal to 2 pi over t0. So it is equal to 2 pi over 2 pi. Therefore, it is equal to 1. This means that the Fourier series representation of x of t will be k running from minus infinity to plus infinity, ak e to j k t. Since omega 0 is equal to 1, as you see here, we insert omega 0 equal to 1, and the complex exponential signals are the harmonically related signals e to j k t, where k is the integer index running from minus infinity to plus infinity. Okay. Next, how do we evaluate the coefficients ak? ak is equal to 1 over t0 from an arbitrary t0 up to that t0 plus capital T0 of x of t e to minus jk omega 0 t integrated with respect to t. Now our t0 is 2 pi, so we have 1 over 2 pi. Okay, so as long as we integrate over a period, we obtain the values of the coefficients. But let us choose the most convenient interval. Let us choose t0 equal to 0. So our integral will be an integral from 0 to 2 pi of x of t e to minus j k, and omega 0 is equal to 1. Therefore, okay, let us not write it like that. E to minus jkt integrated with respect to t. Now we know that x of t is only non-zero from 0 to pi. Therefore, this integral will be from 1 over 2 pi, the integral from 0 to pi of sine t e to minus j k t integrated with respect to t. Now, to evaluate this integral, we do the following. We write down the expression of sine t in terms of the two complex exponential signals, e to jt and e to minus jt. So sine t is e to jt minus e to minus jt divided by 2j e to minus jkt integrated with respect to t. So this becomes, we can take 2j outside the integral as 1 over 4 pi j, the integral from 0 to pi e to j 1 minus k t minus e to, okay, again let us write j minus 1 minus k t, okay, this expression integrated with respect to t. Okay, now let us continue with the details of the calculation of this integral expression. Okay, let us write down ak. The coefficients are evaluated in terms of this integral from 0 to pi e to j 1 minus kt minus e to j minus 1 minus k t integrated with respect to t. Okay, now let us evaluate the integral as follows. 1 over 4 pi j. We have e to j 1 minus k t divided by j 1 minus k minus e to j minus 1 minus k t divided by j minus 1 minus k. Okay, then we have to evaluate at the integration limits 0 and pi. Now here we should mention an important detail. Now as you see, k may take any value from minus infinity to plus infinity. But when k is equal to plus 1 or minus 1, we have a division by zero problem. Therefore, we write this expression for those k different from +1 or -1. Okay, so for k different from +1 or -1, we can evaluate AKs from this expression, and we are going to see we are going to calculate the case k equal to 1 or k equal to -1 separately. So for k different, magnitude k different from 1 or k different from +1 or -1, we have 1 over 4 pi j. Then we have e to j. Okay, let us write this complex exponential as the product of two complex exponential terms, e to j pi, e to minus j k pi. When we substitute pi for t, and when we substitute 0 for t, we get 1 divided by j 1 minus k minus e to minus j pi. In a similar way, we separate these two terms, e to minus j pi, e to minus j k pi, and when t is equal to 0, we have -1 here divided by j -1 minus k. Okay. Now e to j pi and e to minus j pi, these are equal to -1. So this is -1. This term is also -1. Now, what can we say for e to minus j k pi? Now, let me write it over here. E to minus j k, e to minus j k pi is equal to -1 for k odd, for odd values of k, and it is equal to +1 for k even. Okay, for even integers, e to minus j k pi is 1. For odd integers, it is equal to -1. Therefore, now for even integers, okay, for even integers, since e to minus j pi or e to j pi are equal to -1, and for even integers, this term will be equal to 1. Therefore, we will have a non-zero value, but when k is equal to odd, these terms will become equal to 0. Therefore, this will be equal to 1 over 4 pi j. Okay, we can write this as follows. It is -2 divided by j 1 minus k minus -2 divided by j -1 minus k for even k and 0 for odd values of k. In other words, this will be for even values of k, we will have ak equal to 1 over 4 pi j. Then we have, we have a cancellation in fact. We have, as you see, j times j is equal to minus 1, and we have minus sign in the denominator, and we have a cancellation with 2 as well. Therefore, we can write this as 1 over 2 pi 1 over 1 minus k minus 1 over minus 1 minus k. So this will be equal to 1 over 2 pi minus 1 minus k minus 1 plus k divided by 1 minus k, and then we can write this as 1 plus k with a minus sign. So these k terms will cancel out, and we will have minus 2 in the numerator, but there is a minus sign in the denominator as well. So we will have 1 over pi 1 over 1 minus k squared. Okay, so for even values of for even values of k, ak turns out to be equal to this expression. For odd values of k, ak is equal to 0. However, we are going to deal with the case minus 1 and plus 1 separately. So this is for k different from plus 1 or minus 1, or magnitude k not equal to 1. For odd k, ak's are all 0, but k is not equal to plus or minus 1, so that case will be studied separately. Okay, so let us look at that case. Okay, ak was equal to 1 over 4 pi j from 0 to pi e to j 1 minus k t minus e to j minus 1 minus k t integrated with respect to t. Now we are going to calculate a1 and a minus 1. So a1 is equal to 1 over 4 pi j from 0 to pi. Now when k is equal to 1, this term becomes 0. Therefore, this complex exponential is equal to 1. And the other term is e to minus j 2t integrated with respect to t. So this is equal to 1 over 4 pi j. Now the integral is t minus e to minus j 2t divided by minus 2j, and we are going to evaluate this at the integration limits 0 and pi. So this becomes 1 over 4 pi j pi minus e to minus j 2 pi minus 1 divided by minus j 2. Okay, e to minus j 2 pi is equal to 1, therefore this term will be equal to 0, and therefore a1 is equal to 1 over 4j. Okay, a minus 1 is equal to 1 over 4 pi j. Now, let us look at this integral expression. The first term is e to minus j 2t. And the second term is equal to 1 because the exponent will be equal to 0. And we have the integral of this expression from 0 to pi. But if we compare a minus 1 and a1, we see that a minus 1 is just minus a1. Therefore, a minus 1 is equal to minus 1 over 4j. Or, since j is equal to 1 over j is equal to minus j, you can write this as minus 1 over 4j if you wish, and this one as 1 over 4j. Okay, thanks for watching.